memcp is a in-memory database. One of the goals is to offer a platform for REST APIs. Welcome to this short introduction into memcp. memcp is a in-memory database, a storage engine, and a SQL engine that is capable of doing both OLAP and OLTP workloads. So you can have at the same time workloads running with thousands of users, and in the same time let some business analysts make queries over the whole database and do statistics. And this is possible through a very sophisticated storage engine that can rebuild itself within seconds. And let's make a short dive in. The whole engine is written in Go, and we start the shell, and we have a scheme shell here, so we can put random scheme expressions here. This is also capable of doing strings. Concat hello world. This is also capable of doing string computations. Let's take a look at our test scheme file. The database itself provides a HTTP handler. By default, this shows a 404 not found. So if I curl localhost it will yield a 404 not found. But I can also say import test scheme, and when I import the file, it will load a database into it, and it will also install a HTTP handler at /foo. And when I query this, I will get out a result, namely all postal numbers that refer to the city of Dresden. And when I time this, I get something like 26 milliseconds for this time, and now I get around 5 milliseconds. And this has to do with indexing. So at this time the index was not built yet, and now I get the index. If I do the query, I can also take the query and put it into the shell. And the raw query time is only a quarter of a millisecond, so 264 microseconds. I could also take another query to get the to fetch only one postal code, and this will only take 61 microseconds. And the way these queries are built is you have the scan function that you call on the database, then you specify a table that you want to scan, then you have a expression where you filter the values, and then you have a expression what to do with the results. So you can write query plans in Scheme, and the SQL compiler will compile SQL down to Scheme query plans. And the extraordinary thing with this is that the function scan will parse this condition and will look which indexes it can apply. So this is the reason why it only takes 61 microseconds to fetch this point of data. I can also benchmark the whole thing with Apache benchmark tool. With 1 million requests, with 100 concurrent requests. This will take a bit of time. The storage itself is column based, So you have full analytical speed, and also columns are compressed. So if you have a column of integers, the database will compress these integers. So if you only have values between 0 and 3, you only need 2 bits to store each value. So here's the test result. The query throughput was 31,000 queries per second. This is quite a cool result with 3 milliseconds per request HTTP. Yeah, it's a columnar storage engine, and it has 2 storages. It has a main storage, which is columnar, and it has a row storage called the delta storage, which is row based. And all changes are pushed into the row based storage, so it can handle OLTP workloads very well, so writing queries. And as soon as the delta storage is full, the main storage is rebuilt, so all values go back into the main storage, and the main storage is built again and is compressed with the best compression. And we can also go into call the stat function. Stat will print out the memory statistics. We can so the whole database only requires 21 megabytes in RAM, while it was more than double the size on the hard disk. And this means you can store massive amounts of data because the data is compressed very well in the RAM. So what's next? There's a lot of coding jobs here. There's a lot of coding to do. The storage has already has a general purpose value storage, a sparse value storage with where the most values are null. Then there's a string storage which does dictionary encoding, and there's a integer storage with bit compression. There will also be later a sequence compressed integer storage, so you can have sequences like 1, 2, 3, 4, 5, which will be stored in a more compressed manner. And indexes the index.go library will find out the best index for a given condition. The scheme network.go is a wrapper for Golang's network HTTP library, which is very, very, very fast, as you saw in the benchmark. Every query to the database is a HTTP query with like bearer authentication or something like this. And the result will be passed as a JSON-L stream. So we work a lot with JSON-L data. JSON-L is a format where you have each line in a text file is a JSON line, is a JSON object, and so you can stream large amounts of JSON data without getting into memory problems. The next step is to build the SQL parser and SQL engine, so you can post a SQL query and will get back the result. This is basically the interface for the engine, but the engine is not restricted to SQL. You can also invent or introduce any query language. You just have to implement the parser in Scheme. We added some extra features to Scheme, like regex pattern matching, which makes up great lexers and parsers. Very convenient. You can create your own parsers. You can use the storage engine. You can also use the storage engine as a standalone Golang library. It's very convenient. You have a very cool interface. Basically, it's just this column storage interface with get value and a record ID. Since the storage is never changed, you can rely on the record IDs, but you can also use Scheme and extend the whole engine. You can do AI workloads in the memory database. You can do anything. You can add libraries that will call some APIs. You can implement triggers that do something. It's very flexible. One of the goals is to offer a platform for REST APIs. So with memcp you can implement your own REST API, which will directly sit in the same memory space as the database. And this makes your applications ultra fast. So like you saw in the benchmark, you can achieve this performance and do microservices development with it. You can implement high performance REST APIs. In Scheme is very easy to learn, very primitive language that has very powerful features. Yeah. Be invited to check out the GitHub repository as soon as it's released. Before we will release it, we will add at least the SQL parser, rudimentary SQL parser, and some test benches like TPCH or TPCC. Let's see. And after this, we will release the GitHub repository and you can check it out. You can try the code yourself. You can try to create your own applications on top of the memcp platform. Yeah. Let's stop at this point. There's much more to tell, like all the internals, how it works, but this is basically the beginning.